This video covers retest review 11 over factoring, and the deadline to take that test is Wednesday, February 13th. So they ask us on all of these to factor completely. We're factoring 1 through 10 or 1 through 11 and then some other things on 12, 13, and 14. So when I factor, when I'm looking at problems 1 and 2, I am reminding myself that this could potentially be a difference of squares. First, it has to have two terms, which it does. Second, it has to have subtraction, which it does. And third, you have to be able to take the square root of both terms. So I need to check that. So the square root of a squared is a. The square root of 144 is 12. So this is a difference of squares. Difference of squares on your formula chart looks like this. It is important that you use a formula chart on your retest. So we started with this, a squared minus b squared. We have now found a and b, and I plug them in. So instead of a, I put the letter a. Instead of b, I put 12. Instead of a, I put a. Instead of b, I put 12. Problem 2 also only has two terms, so I'm looking to see if this is a difference of squares. Also, because this one has a number in front, I need to check for a GCF, so I'm going to click Math number 9, and I'm looking between 16 and 25, so I type those numbers in, no signs, and there is no GCF. So difference of squares has to have two terms, has to have a subtraction, and you have to be able to take the square root of both terms. So the square root of 16 is 4, the square root of x squared is x, the square root of 25 is 5. So this is my a, this is my b. Remember, you start with a squared, so whatever is in front is a, whatever is behind is b. So I do a minus b and a plus b. Problem 3, this one does not have two terms, so it is not difference of squares. So I look for a GCF, but because my leading term is a 1, there is no GCF. So I can look to see if this is a perfect square trinomial. And perfect square trinomials are a squared plus or minus 2ab plus b squared. And then my result is a minus b squared. So I need to see if a squared can take the square root. So can I take the square root of x squared? Yes, I can. Then I need to check if b in the back is squared. So can I take the square root of 81? Yes, I can. Then I need to check that middle part. So negative 2 times x times 9, so my a and my b. If I plug that in, do I get back to the middle term? Yes, I do. So my answer is a minus b squared. So a, which is x, minus b, which is 9, squared. If you do the box, you would get the same answer. Your box would just have x minus 9 on the top and x minus 9 on the side, and you would just need to recognize that's the same thing. So problem 4, looking for a GCF. I have a leading term of 1, so there is no GCF. This has 3 terms, so let me see if it is a perfect square. So can I take the square root of a squared? Yes, I can. If the back is b squared, can I take the square root? Yes, I can. If I do 2 times a times b, does that get me back to the middle term? Yes, it does. So I use my formula. This fits in my formula, which is what we check. So this is us checking to make sure that it fits this formula. This is how I write my answer. So a is x, b is 12, and x plus 12 is squared. Problem 5, this one has 3 terms, so I'm not looking at a difference of squares. I notice all 3 of these have letters. I'm also going to check my numbers. So if I go math number 9 twice, and I do 2, 8, close parentheses, 10, I can see that there is a GCF of the number 2 and then the letter A. So I'm going to divide out a 2A from all 3 terms. So 2 divided by 2 cancels. A cubed divided by A is A squared. 8 divided by 2 is 4. 4 squared, or A squared divided by A is just A. Negative 10 divided by 2 is negative 5, and my A's cancel. So from here, I'm using this, the A squared plus 4A minus 5, for my box. And I just mentally said that the square root of 5 is not pretty, so I can't do a perfect square on this one. So in my box, I put my first and my last term, so the A squared and the minus 5, and then I multiply them for my product. And then my sum is in the center, so my sum is 4A, and my sum does not go in my box. In my calculator, I am going to put the product divided by x into y equals. So in y equals, up here on the top left, I put my product of negative 5 divided by x, and I go to the table to search for the sum. So I am looking, I think I can, nope, sorry. So my table right here, I am looking for a row horizontally that adds to 4. Remember, I do not use anything that has decimals. So I usually start at 0, which always gives me an error. 1 minus 5 gives me a negative 4, but I need a positive, so I'm going to keep going. Decimal, decimal, decimal. 5 minus 1 adds up to 4. So from the calculator, I have a 5 and a minus 1 for my GCFs. So my final piece is to take out GCFs vertically and horizontally. So vertically, I'm looking at A squared and negative 1A. They only share an A. 5A and negative 5 share a 5. And then horizontally, A squared and 5 share an A. Negative 1 and negative 5 share a negative. Remember, if I do a quick check, A times A gives me A squared. Negative 1 times 5 is negative 5. So my full answer is my GCF that I took out way at the beginning, and I have to remember to put that back. Top term and bottom term. It does not matter which order you put the terms in as long as you have them in the correct order. Problem 5. There is not 2 terms, so I don't use difference of squares. I am going to check to see if I can get a GCF out of this. So I click math number 9, math number 9. Oh, cute. Math, scroll right 9, math, scroll right 9. So I'm looking between 5 and 30 and 40. And my GCF is a 5. So I'm going to divide a 5 out of all of these. Now this one, it would not be 5v because they do not all share a v. So 5 divided by 5 cancels, and I'm left with v squared. Negative 30 divided by 5 is negative 6, and 40 divided by 5 is 8. I will now use what's left in parentheses for my box and the P and the S. So my box is the first and the last terms. My product is those two things multiplied together. Sum, excuse me, sum is in the center. Excuse me. So in y equals, I put the product divided by x. So I put 8 divided by x. I go to the table and I search for the sum. Well, let's see, my cursor's on negative 4 and negative 2. If I'm not sure, remember you can go second quit and do negative 4 plus negative 2. And oh look, that gives me a negative 6. I do need to put my signs. The signs absolutely 100% matter because if I don't have the right signs, my answers will not work out the correct way. So vertically, v squared and negative 2v share a v. Negative 4v and 8 share a negative 4. If you don't remember what numbers they share, the calculator can help you. Math number 9, I'm looking between 4 and 8, and it will remind me that it's 4. Remember yourself that the signs come from the inside number. So whatever the inside sign is what your inside sign will, or your outside sign will be. V squared and negative 4 share a v. Negative 2v and 8 share a negative 4. If I do my very quick check, v and v is v squared. Negative 2 times negative 4 is 8. So my full answer is that GCF I took out, factor and factor. Some of you might remember that if you have a v squared with no coefficient in front of it, the factors you get from the calculator, negative 4 and negative 2, can be written for your answer. If you remember that, you can use it. Just be very careful when using it. Problem 7, I see 3 terms, so this is not a difference of squares. If I do math number 9, I'm looking between 9, 9, and 2, and they do not share any like terms, so my G in GCF is none. If I try to take the square root of 2, it does not work, so I will need to use my box. I put my first and my last term in the box, and I multiply them for my product. My sum is in the center. In y equals, I will put the product of 18 divided by x into y equals. Put product, put product. Then I will go to the table and search for my sum of negative 9. Now here I have a negative 3 and a negative 6, which adds up to negative 9. So negative 3 and negative 6. And then I take out my GCF. So 9 and 6 share a 3 as well as an x. Again, remember you can do math. Oh, hold on. Math number 9 between 9 and 6, and it will tell you that it is 3. 3 and 2 do not share any numbers, so we use a 1 as a placeholder. 9 and 3 share a 3, and x squared and x share an x. Negative 6 and 2 share a negative 2. Please be careful. If you are the type of person to say negative 6 divided by 2 is negative 3 and write negative 3 on the outside, then you need to make sure that you are really watching your steps and using that calculator. Quick checks, 3x times 3x is 9x squared. Negative 1 times negative 2 is a positive 2. So I rewrite my factors as my answer. Problem 8, I see 3 terms. 3 and 5 are both prime, so there is no GCF. You could also put 1. So my first term and my last term are listed in my box. I multiply them, signs included, for my product. And then my sum is in the center, so 14x. In y equals, I put the product divided by x. So negative 15 divided by x. I will go to the table and search for a positive 14. So 1 minus 15 is negative 14 decimal. 3 minus 5 is negative 2 decimal. 5 minus 3 is 2 decimal, 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 decimals. 15 minus 1, oh, that gives me a positive 14. So I have a positive 15 and a minus 1. Remember that you do need to put the x's in writing your factors. So 3x squared and 1x only share an x. 15x and 5 share a 5. 3x squared and 15x share a 3 as well as an x. And -1 and -5 share a -1. If I do a quick check, 3x times x is 3x squared. 5 times -1 is -5. So my factors are x plus 5 and 3x minus 1. Problem 9, I see there could be, none of these are prime numbers, so let me just double check. Math right 9, math right 9. I'm looking at 4 and 10 and also 6. Oh, sorry, that's 20. And they do share a 2, so I will need to divide out a 2 from all of these. 4 divided by 2 is 2, 10 divided by 2 is 5, 6 divided by 2 is 3. So my G in GCF is 2. I try to take the square root of 3 and it does not work, so I will need to use the box. This is not a perfect square. So first term and last term go in my box and multiply for my product. My sum is in the center. So in y equals, I will put my product divided by x. So 6 divided by x. I will go to the table and look horizontally for a 5. So 3 plus 2 will add to 5. They're both positive, so I keep them both positive. 2x squared and 2x share a 2 and an x. 3x and 3 share a 3. 2x squared and 3x share an x, and 2x and 3 do not share anything, so we use a 1 as a placeholder. So quick check, x times x is 2x squared, 1 times 3 is 3. So my full answer is my GCF of 2, top factor and bottom factor. Problem 10. I don't have 2 terms here, so I'm going to check for a GCF, and you should check for a GCF with 2 terms. I'm just knowing that I'm not looking for a difference of squares. So 15 and 12, also 3. They do share a 3, so I'm going to divide out a 3. 15 divided by 3 is 5. 12 divided by 3 is 4. 3 divided by 3 is 1. So I put my first and my last term in the box and multiply them for my product. If you haven't caught on so far, I always write these in here first and then multiply them for my product. And my sum is in the center. So if you struggled on that test to remember what goes where, not only do you need more practice, but you need to make sure you're putting the right things in the right spots and be intentional about your practice. Practice it the exact same way every time. So my product is a -5 divided by x goes in y equals. Go to the table and search for the sum. So 1 minus 5 would get me a -4. Sorry, that's +1. And a -5. And then I factor out GCF. So 5 and -5 share 5, x squared and x share an x. 1 and 1 share a 1. 5x squared and 1x share an x. -5 and -1 share a -1 only. So x and 5x share a 5x squared. 1 and -1 multiplies to -1. So my GCF is 3. 5x plus 1, x minus 1. Problem 11, this one does not have a GCF because there's just an x squared. I can't take the square root of -18, so it is not a perfect square trinomial. So I put first and last in the box and multiply them for my product. My sum is in the center, so I will put -18 divided by x into y equals and search for a +3. So 1 minus 18 is -17, 2 minus 9 is -7, 3 minus 6 is negative 3, but I need positive, decimal, decimal. Oh, 6 minus 3. So I have a 6 and a minus 3. And then when I take out my GCFs, they will be x plus 6 and x minus 3. This is one of those faster ones because anytime you have just an x squared, the factors you take out and put into your box are the exact same answers as your factors. Problem 12 asked me to simplify this algebraic expression. So I'm going to take 4 and distribute it. So 4 times x squared, 4 times negative 4x, and 4 times 6. I'm going to do the same thing with negative 2x. So negative 2x times x is x squared. Negative 2x times negative 5 is a positive 10x. And then I finish by combining like terms. So I have two sets of x squareds. 4 minus 2, I do exactly the signs that it says. So 4 minus 2 is 2, and that's how many x squareds I have total. X's, I have a negative 16 and a positive 10. I do exactly what they say, so negative 16 plus 10 is a negative 6. And then number-wise, I have 24 and nothing else to change that, so I simply rewrite. 13, they want us to find the product, so this time we're being given the outsides and we multiply to find the insides. So when you multiply, you don't have to write this if you feel like you don't need it, but I want to make sure you know where it's coming from. We do top times side, top times side, top times side, and top times side. So 4 times 4 is 24, x times x is x squared. Negative 3 times 6 is negative 18, and then an x. 4 times 1 is 4, and then an x. Negative 3 times 1 is just negative 3. So my last step is to combine on the diagonal. I have negative 18x's and 4x's. I combine them to get negative 14x. So my full answer is 24x squareds, negative 14x's, and a minus 3 to finish off that problem. Problem 14 asks us to find the perimeter of a triangle when given all three sides. So to find the perimeter, you add all the sides. So this is just more combining like terms. So x squared, I have 5, 3, and 1. I do exactly what it says. So 5, 3, and 1 is a total of 9. X's, I have 6 minus 2 minus 1. So 6 minus 2 minus 1 is 3. And then numbers, I have negative 1, negative 4, and 7. So 7 minus 4 minus 1 is a positive 2.